So good afternoon, everyone. My name is Kelsey Storzinger. I'm an assistant professor at Oregon State University in the Chemical Engineering Department. And today I have with me PJ and Cindy, who are two students at Oregon State University, also in chemical engineering. And today we're going to show you how you can use some just materials you have at home to split water. So we're going to explore what makes up water and learn about different things that are involved in this chemical reaction. So I hope you're excited. We're really excited. And if you have any questions, you can always just let us know. Or if you have questions after the fact, maybe you're watching this as a recording, you can contact us by email by Googling our names. So we're going to get started. So there was an experimental materials list that you might have seen on the website. To review and give you a minute to grab what you might need. You'll need something conductive. So two things that are conductive. Here I have two pencils that I've sharpened on both ends. So the core of the pencil, the graphite, is a conductive material. I'll talk about what that means in a little bit. You could also use mechanical pencil lead. Maybe you have that and it's a little bit easier. Later we'll show you what happens when you use paper clips too. So, but I'd recommend starting with the pencils if you have all your different options available. The other things that we'll need is we're going to use a 9-volt battery. So this is like the battery that's in your smoke detectors. Don't take it out of your smoke detector though. Make sure that's always powered. But you can use one for that. And then you'll need 2 pieces of, you could use wire, or I have a little fancier wire that has clips on both ends to make the experiment a little easier to show you guys. But if you had wire that was covered in an insulator, like a plastic, you'd want to strip that off so you have bare ends of metal wire that you can use to connect your battery to your pencils. The other thing that you're going to need is you're going to need a cup. I'm just using a clear plastic cup so you can see what's going on. You'll want to use something you can see through too, so you can see what happens when you apply energy to your materials to split water. And you'll also need some water. So this is just tap water. I just pulled it out of the faucet a minute ago. Maybe fill your glass half full or so. And we'll talk about different materials within this water glass that then might make the reaction go faster or slower. I'm also going to use a piece of cardboard to help hold everything in place. And what I'm going to do is I'm going to take my 2 pencils and I'm going to poke them through this cardboard. Actually, I think I'm going to cut some slits in my cardboard to make it a little bit easier. I'm just going to cut through. Okay. So now I have 2 places where I can easily put my pencils. I'm going to put my pencils through. Again, these are sharpened on both ends because I care about the graphite, the pencil lead, which is on both ends that I'm going to connect my wires to and then connect my battery to. Okay. So I've got my 2 pencils through my cardboard, and now I'm just going to put this in my water glass. It's just a water. I have a T on there for tap water. I'm going to submerge my pencils, adjust the height a little bit so you'll be able to see what I'm doing. And now what I'm going to do is I'm going to take my 9-volt battery, and I have my 2 wires. I'm going to connect the positive end. I'll use a red wire for that. I'm going to connect this positive end. You can see there's a little positive and negative on my battery. We'll talk about that, what that means too. I'm going to connect the positive end to one of my pencils. And then I'll connect the negative end. I'll use a black wire for that, to my other pencil. Now I'll hold everything up so you can see it. Here I've got my battery. I have 2 leads and I have my 2 pencils connected to that battery. Now I'll give it a minute and we'll talk about what we just set up. So what we just did was we took a battery that's giving us energy in the form of electricity, and we connected that to 2 things that I said are conductive. That means that they conduct electricity, or they conduct the flow of electrons. And if you think about what's conductive or what's not, you might think about like your charging cable that you have for, say, you're charging up a cell phone or some other device. When you plug that into the wall, into an outlet, you have two metal pins which are going into the socket. And then it's coated in some plastic material, which is keeping everything insulated so you don't encounter the electricity. So the metal, the part that's going into the wall, connecting to the outlet, that's a conductor. And the insulating part that's protecting you from that electricity is what we call an insulator. So we said that we used two conductive things. Those are my pencil leads. And we're applying an energy to them in the form of a voltage from my battery. And I'm doing something cool with it. So what am I doing? Here, if you look really closely at the tip of my pencils, you'll see that I am generating bubbles on them. So let's talk about what's happening, right? When do you usually see bubbles in water? You might see it when you heat it up. Maybe you're making some pasta on the stove. Are we heating it up right now? Probably not. If I touch my cup of water, it's still room temperature. Maybe it's a teeny bit warmer just because of what I took out of the faucet, but it's not boiling. And if you look closer, you might notice that I have two different amounts of bubbles on those pencils. It's a little hard to see over the lip of my container. So on the one that is connected to the black wire, that's the one on this side here. This side here, I have more bubbles compared to the one on the right side, the one connected to the red wire. So why is that? PJ will talk a little bit more about that later. But what's happening is we're taking water, which has the chemical formula H2O, and we're splitting it. And when we split it, we have 2 parts hydrogen for every 1 part oxygen. So on the negative end of our battery, that's what's with this black wire here, we have twice the number of bubbles compared to what's coming out at the positive end, which is the oxygen. We just have 1 part of that. Okay. So that's pretty cool, right? We just took water out of the tap and we just made hydrogen and oxygen from that water using a battery, right? Let's talk a little bit more about that tap water, because now I'm going to give you an experiment to try. So something you could do is, instead of taking tap water, you could take, where's the label? Some distilled water. So this is water that's been treated to take what we call ions out of it. So you can just get that at the grocery store. Sometimes you use it to fill up different things in life where you don't want to have a problem with stuff forming on them. So we just have this DI water. I'm going to top off my glass so you guys can see it a little bit better. So I'm going to pour some more DI water in here, distilled water. And now I'm going to put my 2 conductors, my 2 pencils in to this distilled water. And what do you think is going to happen? Do you think I'll get just as many bubbles, more bubbles, fewer bubbles? All right, I'll get it all set up so you can see a little better this time. This isn't very exciting, is it? There's no bubbles forming. So to better understand what's happening, we can think about what's different with these 2 waters. One came out of the tap, and then this one was distilled. I said they took out the ions from it. So when I say ions, what do I mean? Well, in the field of science that we're doing called electrochemistry, we talk about electrolytes. You might have heard the term electrolytes, right? Sometimes they talk about them in Gatorade commercials or something like that. So maybe the problem is that I don't have electrolyte in my distilled water. We can experiment, right? We can test that guess, an educated guess we call a hypothesis. And let's do it by using something with electrolyte. So I have here some vitamin water, just like Gatorade. It's just a little easier for you guys to see through. I'm going to put some of that in a glass instead. And maybe we can make the hypothesis that if I have some electrolytes in my water, I'd better be able to split it. So let's try that. Okay, I'm going to take my pencils connected to my same 9-volt battery, and I'm going to put them in my vitamin water. Okay, what do you think is going to happen? A little hard to see, huh? We can get some light. Can you see some bubbles forming? Like a spooky experiment. So we have more bubbles again forming on our black connected pencil compared to our right one, our negative electrode compared to our positive. So we put some electrolyte into our water in the form of vitamin water, and we were able to make this split and form hydrogen and oxygen again. So let's go a little farther with our hypothesis, right? Because now we just compared tap water, distilled water, and vitamin water. But can we make our distilled water act like our vitamin water? Can we add something to it to make it behave like an electrolyte? So I'm going to do that by just adding some baking soda. You could also use table salt. I would only use a little bit though, just to be careful and safe. So here I have my same distilled water glass. I labeled it DI. And I'm just going to add some baking soda to this. So I just have some baking soda. I'm going to add some in. Whoop. You definitely don't need that much, even just a little bit would do. So, but I have some baking soda in here now. And now I'm going to put these pencils connected to my battery in again. And we'll see what happens. Okay, now we're getting exciting. So what do you see? I took my distilled water. Remember, this was the water that nothing happened when I took my battery and connected it to my pencils. I just added some baking soda, and now I see bubbles forming on both of my pencils. Now, the pencil that's under the one that says DI, this is connected to the black lead. That's the one that's generating hydrogen. And it's not the most quantitative analysis, but you can see there's more bubbles forming on the hydrogen pencil compared to the oxygen one, because we have 2 pieces of hydrogen for every piece of oxygen that make up water in H2O. So the next thing we can do is learn a little bit more about the energy we're applying to the system. So I said, okay, you have a 9-volt battery. This applies energy. It's in the form of a voltage and it's electricity. But can we learn a little bit more about what's actually happening? So let's experiment some more. Let's say, okay, well, we used a 9-volt battery. What if we use a different type of battery? So you probably have some AA batteries lying around at home. Here I have a few of them. So again, these have positive and negative terminals. You can see here on this end is labeled plus. That's because it's positive. We'll connect that to the red clip. And we have a negative sign. That's the negative terminal. We'll connect that to the black one. So I'm going to do that now. Here you'll probably have to, if you're using these nice clips, you still have to tape them to your battery. It's a little trickier to get them to stay on. Just need a little more tape. So now I've just connected my positive, my red lead to the positive terminal and the negative, the black, to the negative. Tap off my residual bubbles from before and we'll see what happens. Okay. So this is that same water with added electrolyte in the form of baking soda. But now, instead of applying 9 volts from our 9-volt battery, we're just using a AA battery. And a AA battery, if you look closely on the label, is only 1.5 volts. So that's giving less energy to our system. And it looks like that energy is not enough of a push to make our reaction happen. So we've learned some things, right? We know 9 volts works and 1.5 volts doesn't. But what about all that space in between there, right? How much energy does it take for this to happen when we have pencils as our conductors? We can adjust how much energy we apply to our system by taking more batteries. So here I have another AA battery. And what I'm going to do is called connect this battery in series with my other one. So I'm going to stack them. The way I do this is I go positive to negative, positive to negative, positive to negative. So I make a big long battery chain. So first what I'll do is I'll connect 2 batteries. So here I have 2 batteries. And if I add up the voltages, now I will get 3 volts. 1.5 plus 1.5 is 3. Okay, so now I have my 2 batteries connected. I still have 1 positive and 1 negative end exposed. And I'm going to connect those to my 2 pencils again in my electrolyte plus water. And what do I see? Still not a whole lot, huh? So 9 volts worked, 3 volts doesn't. So maybe we're getting closer, right? You know, eventually if we get up to 9 volts, this will work. Let's try adding 1 more. I'm going to stack 1 more battery. Positive to negative, positive to negative. And this is called connecting them in series. And I still have 1 positive end exposed and 1 negative end exposed. So now I have a stack of 3 batteries. And what do I see? Still not so much, but maybe if we just wait a little bit, we might get some more. Or we can always just add another battery, right? So should we do 1 more? So far we have 1.5 plus 1.5 plus 1.5, that's 4.5 volts. We'll add 1 more to get 6 volts. So I have 1 more here. Take some tape and I'll add it to my stack of batteries. Fix my tape somewhere else along my chain of batteries too. Okay, so now I have a chain of 4 batteries connected. 4 times 1.5 is going to be 6 volts. So I have 6 volts that I'm applying to my pencils. And now what do we see? We're starting to see some bubbles, huh? A little hard to see probably over the Zoom. Mix things up a little bit more. There we go. Now we can just start to see the formation of bubbles on our 2 pencils. So these are forming on our pencil tips. And if we waited longer, we'd see that these bubbles grow over time as our reaction goes forward. So as our hydrogen and oxygen start to form on our 2 pencils. Now there are other ways you could always speed up this reaction too, right? The one we just talked about is making more of a push for the reaction to go forward. And we did that by using a different battery source, a different amount of energy to drive it forward. Another thing we could do is we could change what is inside the cell. So we could use a different type of conductor. We talked about, you could use pencils, you could use paper clips, and we'll talk about that in a little bit more, a little bit further down the line. But first, what we want to do is we want to take you into the chemical engineering lab that we have at Oregon State, where PJ is going to show you how we might do this in a little bit more quantitative manner. So we talked about how we can see differences in bubbles being formed, and PJ is going to be more quantitative and actually measure this. Take it away, PJ.
All right. Hello, everyone. I am PJ. As you can see, I'm all masked up with my hand gloves, orange color, go Beavs. And I'm in our chemical engineering lab. So I'm going to try and show you this experiment, which is the Hoffman cell. So it's pretty much what you're going to try at home. This is a glass, and these 2 are your pencil leads down here, the pink things that you see, it has a wire that goes all the way in, and it gets in contact with something called as electrolyte. So in here, we have a transparent electrolyte, as you can see. So this is just you can think of it as Gatorade. And this is going to be my power source, or the push that I'm gonna get is through this particular device, which is also called as a potentiostat. So these are the two leads. As you can see, I have a black lead, which I would connect it to the negative side. And then I have a red lead, I'm gonna connect it in here. And the next thing that I'm gonna do is turn the potentiostat on. As soon as I turn it on, I've already set it to 12 volts. So hopefully it'll go to 12 volts, and then we'll see what happens. So as of now, if you see in here, it's completely filled with a liquid, which is the electrolyte. There's nothing in there. And one more thing, like you can also see the markings in here. So it's exactly going to be what you would do at your house. But then in here, we'll be able to measure how much gas we would form, or how much hydrogen and oxygen we're going to form. So all I'm doing is turning the potentiostat on, shows about 12 volts. And then I'm going to start the timer. And if I zoom in, you should be able to see a lot of gas being formed here. And a teeny tiny bit of gas being formed in here. So based on what Kelsey explained, you should be able to know what electrode of which gas this would be, wherein you form a lot of gas, and which gas would this be when you form less electrolyte. And if we go up here, you should be able to see some bubble formation. And in here, you'll see less bubble formation. So what I've done is I've started a timer in here just to see as to how much time it takes to reach a particular level. And I'll be back soon once I have a particular level. Maybe let's just go for 6 or 8 in here, up to 6 or 8 markings in here. And then we'll talk more about which gas was formed more. Over to Kelsey.
Thanks, PJ. Yeah, so isn't that cool? Now we went from, instead of just looking at the number of bubbles being formed, PJ is working on quantifying just how much we made. And we could expect that we should get twice as much hydrogen per every amount of oxygen we have, because we have H2O, 2 parts hydrogen for every 1 part of oxygen. Now, remember before we had some water, we took some what we call distilled water. So this was water that they took all the ions out of, and then we added ions of our choice in. And we did that with baking soda. We call this an electrolyte, right? This was like Gatorade. And we connected it to our battery, and we can see here that we have bubbles forming, and we have twice as many bubbles, more or less, PJ is quantifying it, on our negative pencil. That's the one connected to the black lead, and about half as much forming on our oxygen one that's connected to red, the positive terminal. So we talked about ways you could speed this up, right? You could put something in your water that might make things go faster. We added baking soda to make things go faster. You could apply more of a push. So you could use a higher voltage. PJ was using 12 volts. Here we're only using 9 volts. Use some battery. What if we change the material? So here we have pencils. A pencil has graphite at its core. You call that like a pencil lead. What if we use something else? So remember, we want our material to be a conductor. We want it to be able to pass electricity. Metals are pretty good conductors, right? That's we talked about how if you have a plug, something you're plugging in a device to charge it into your wall, into the socket, you have metal that's going into that socket. So what if we add some metal? Let's find some. So let's take some paper clips. These are just standard paper clips. You will want to make sure you use ones that look like a metal. So we don't want them to be coated in any plastic. They should be shiny. We can't be able to scrape anything off of them. These are just standard metal paper clips, and we can uncurl them just so we can get them in our electrolyte. And then I'll unclip these two pencils we've been using as our electrodes. And instead, we'll use our paper clips. So here I've just put the paper clips in between or I've stuck them through some holes in some cardboard just to hold them up so they don't touch. We don't want the two paper clips to touch, otherwise our positive and negative will go together and we won't be able to apply any push for our reaction to proceed. So let's connect our two paper clips to the two terminals of the wire. So I connect one paper clip to the negative side, that's my black side. Remember, that was the one that made twice as many bubbles. We called that hydrogen. And then I connect to the positive one using this red clip to the other paper clip. That was the one we said was making oxygen. Wow, okay, this is pretty exciting. Are you guys ready? Look at all these bubbles. So you can see the one connected to my black lead, making hydrogen, is making a ton of bubbles, right? There's so many bubbles coming off. And what if we look at the one connected to the positive lead, the red one? Well, something's happening, but there's not a lot of bubbles, huh? We see no bubbles, and there's kind of like it might be hard to see in the camera, but you can try it yourself at home. We see some kind of misty thing coming off of the electrode, maybe a couple bubbles. So what's happening there is something we call corrosion. So we're still making hydrogen on our negative lead. We're making a lot. And this has to do with the fact that we're using a different material than we were using before. But on our oxygen lead, the one connected to the positive, the red terminal of our battery, we're corroding. That means that instead of oxygen coming off as bubbles, what we're doing is we're changing what's on the paper clip. So we have some reaction taking place, which is leading to a different material. And that material likes to dissolve. And that's why we have this kind of cloud coming off of our paper clip into our electrolyte. So far we've talked about how we could change our electrolyte to control the reaction, right? We did this by first comparing it to something like Gatorade, which we knew was an electrolyte, and then adding some electrolyte, we added baking soda. Then we talked about how you could change the push of your reaction. We changed it by using different batteries that had different voltages. And now we just talked about how you can change the material itself to make a reaction go faster or slower. And sometimes different materials will even make a whole different reaction take place. And that's what happened when we started to see corrosion on this paper here on our positive terminal. So now I'm going to pass it back to PJ, and he's going to give us an update on how much hydrogen and oxygen he's made in the lab.
All right, so we've been making quite a bit of hydrogen in here, wherein you can see the level is close to 4 already. Wish you could see this number, but then trust me, it's 4 right here. And in here, as you can see, it's still working towards 2. So looking at this, you should be able to know that it's oxygen is just being like formed, or oxygen is half of what hydrogen is in here. And it's been over 7 minutes and we are still generating quite a bit of gas here. All we have to do is wait for long in order to see as to what the difference is between this particular end, which is generating gas slowly, and this particular end, which is generating a lot of gas. All right. So I'm just going to leave this running for a while. And at the very end, we'll once again take a look at this and see how much gas is formed. All right. In the meantime, I also wanted to talk about something else. So why are we looking into it? Let me grab a chair. So why are we looking into generating oxygen and hydrogen? So what do we want to do with that? So I hope you can see or rather, let me just take my camera and I'll turn this around. So in here, you can see a lot of things, a lot of pieces here. So what am I gonna do here? As we said, you need a source of energy. So in here we have battery, but we also have a solar panel, which of course is a renewable source of energy. It's much cleaner. In here, what we have is something called as a fuel cell, a reversible fuel cell. Think of it pretty much, I mean, it'll pretty much have these two electrodes, and it's just a fancy looking device doing pretty much the same thing. And then we have two different containers, just like the containers or cells that we had in here. And then we have a few tubings here. And now what we're going to do is supply again energy into this, which is trying to push the water to break into oxygen and hydrogen. And then what will happen is in here, if you see, these two levels are pretty much set to 0 right now. This level should go up over time. And if you guess it right, this should, which is hydrogen, should go twice as fast as oxygen. So let's see, I'm gonna change the angle again. As we do not have any sun outside, so we'll unfortunately not be able to use the solar panel, but then I can demonstrate this experiment with once again using batteries here. So I'm gonna connect the black lead towards the negative side and the red lead towards the positive side. And I'm gonna turn the battery on, and let's go back and see what's happening here now. You should be able to see the increase in liquid and over time, what we are doing in here is collecting any gas that we are generating, just like we are collecting the gas in here in separate chambers. So why do that? So think of this as pretty much like another battery, which is much cleaner, and we are just using water and solar energy to store any solar energy as gas in terms of hydrogen and oxygen. So let's see where we are as far as the level is concerned. In here, you should be able to see the difference now. The hydrogen is already at 10, while oxygen is at around 5. Let me see. Yeah, you should be able to see the difference now in liquid level. So the next thing that I'm going to do is turn the battery off, take out these leads. And this is the next important step. So we have energy stored as hydrogen and oxygen right now. And now we're going to convert it back to electricity. So let's see how that goes. So in here, you can see that there's a motor and a stir bar in some liquid. So think of it as a blender. So if you want to run your blender, and if you live in a place wherein you do not get electricity at night, how are you going to run the blender? You could use this as your battery source. So I'm going to go ahead and connect these cables. And now I'm going to connect these leads to my motor. Before I connect both the cables, I want you to see what happens. So I'm still supposed to connect this, and this particular stir bar is not rotating. As soon as I connect this cable, should be able to see that the gas in here, which was hydrogen and oxygen, we are once again combining it back into water, and it gives back energy. Now, this is pretty slow in here, right here. It's taking forever. I mean, I don't want to use a blender that spins so slow. So let's see if we can connect it to something else which may turn faster. So I've made my makeshift fan, and I'm going to connect it to this fan. And as you can see in here, I'm getting some fresh air. So I'm just getting some fresh air using water and solar energy. Isn't that fun? All right, let's see where we are as far as the other cell goes, which we called as Hoffman cell. Let me turn it around. And in here, you can see that we have a lot of gas here, while a teeny tiny bit of gas here. So once again, I'll leave this question to you as to which gas would be in here, and which gas would be in here. And it's been about 15 minutes. All right, over to Kelsey.
Great, thanks so much, PJ. So yeah, now you guys learned how you can split water at home using just a battery and something that can conduct electricity, like we used a couple pencils. We talked about how you can change what's in the water to make the reaction go faster or slower, how you can use different types of batteries with different amounts of voltages. That was a way that we applied a push for the system to drive the reaction faster. And we talked about using different materials too to make this water splitting reaction happen. So we used a couple of paper clips that we unwound and compared them to what happened with a pencil. And we saw that changing the material can make a reaction go faster or slower, or it could even change the reaction that happened, right? We saw some corrosion, we saw some stuff coming off in the water. And then PJ showed you how we can quantify how much oxygen and hydrogen we get by using something in the lab we call a Hoffman cell. And then he showed you the super cool thing we're really excited about. And that's how you can take energy, store it in water by splitting it into hydrogen and oxygen. That was when he used, in this case, a battery, but you could use a solar cell if it was sunny out today, as a way to store energy in hydrogen and oxygen. And then when you want to get that energy back, you use what's called a fuel cell. That's where he connected things in the opposite way to that device he had. And that was enough to power some other device, like he powered either a mixer or a fan. And so hopefully you've learned about what makes up water and what those constituents, the hydrogen and oxygen, can do in terms of renewable energy. So we're really glad you joined us today. And if you have any questions, you can always reach out to us. You can find our contact information, our email addresses on our group website. Again, I'm Kelsey Storzinger, and thanks for listening about what makes up water, how we can split it, and how we can use it in a renewable energy economy. Thanks.